So if you go to labs.google, you click experiments and scroll down, you have learn about, try it now. I don't know if it's available in your country, but I have VPN to United States. So I want to learn about this code. This is coding one of the DeepSeek's latest papers, native sparse attention. So, but you can learn anything here. Biology, chemistry, psychology, whatever. But I want to learn this, and it was really difficult for me to understand this. So let's see what it does. I pasted all of the code. Let's see how this works. How is it gonna help me learn about it? It's already explaining. Okay, we have some terminology to the side, compressed attention, fine attention, sliding window attention, okay. We have some build your vocab, so sparse attention, okay, and then we have some key components of sparse attention. It's bringing images, although these images are not so accurate. Okay, common misconceptions. Attention mechanism always requires attending to the entire input sequence. Okay, sparse attention mechanism can achieve efficiency by selectively attending to subsets of the input. Very interesting. Explaining benefits of no. Let me click grouped query attention. Okay. Now it should generate about grouped query attention. Grouped query attention is an attention mechanism that aims to improve the efficiency of transformer models, especially for faster inference from large language models. It balances the trade-offs between multi-head attention and multi-query attention. Efficiency trade-off, flexibility. In typical attention mechanism, a query queue is composed of set of keys, is compared, to a set of keys. Yeah, I know this. Okay, so this does seem interesting. It also found a video, though this is really cool. I see this being used in some way. How might the optimal number of groups in group query attention depend on the specific task or dataset? Let me reveal. The ideal number of groups in group query attention might vary depending on the complexity of the task and the characteristics of the dataset. Most complex tasks with long-range dependencies may benefit from a larger number of groups to capture more nuanced relationships, while simpler tasks may perform well with fewer groups, reducing computational overhead. Yeah, you want to have more of the things, more of the groups, because if it's more difficult task. Okay, actually I like this, even though this is a very hard topic to teach somebody. And it wrote all of these other blogs and stuff. I mean, it found, not wrote, it found them. So I really like this. I see how this would be cool for medicine, biology, chemistry, and more of these where you need to memorize stuff as opposed to explaining code, because code is a lot more logical. So it's teaching me theory, but I wanted it to explain code, but it's okay. It does seem like on its way to be a good product, good teaching, learning product. Now they also have Notebook LM. So I'm guessing Google is trying multiple different ways or products, and then they're gonna see which one is used for learning, and then they're gonna just focus on that product.